Well, hello everybody, this is Mr. Kinney. I'm going to go over just getting started on the first two problems on the stoichiometry problems worksheet number 1 paper. So when you're doing this, please get out your most valuable player of chemistry, the MVP charts, what I call the road maps. Look at these, this will help you be able to see the big picture on the problems. Now in the first question here, okay, we're starting with 14 grams of nitrogen. So that's what we're starting with. So I recommend, please put N2 over here. In fact, you could even say you're starting here with 14 grams of N2. Now make sure it's N2. The problem says nitrogen, but in this balanced equation, it's N2. And we're looking for how many grams of ammonia are produced. So we're looking for ammonia. We're looking at nitrogen right here in this problem. So I would recommend on your chart, label this compound B is going to be NH3, and we're looking for grams. We want to end up over here. So we practiced on one of our other papers, the mass paper. It's just like this. You start with your 14 grams, that's your given. Your next conversion factor is you're going to divide by the molar mass, which means you put 1 mole of N2 over the molar mass for nitrogen, 28. Then you've got to do the mole-to-mole ratio because you got to jump over to the new compound. And whenever we do this, see here it says moles of B, that's the compound ammonia in this case, the compound we're looking for. That always goes on the top of the mole-mole ratio, whatever we're trying to convert to. And there are 2 moles of ammonia. So when you get to that part, this is the middle, this is the ratio part here, you are going to need to put 2 moles of NH3, because that's what we're looking for, NH3. And in the balanced equation, there's 1 mole of N2. This is kind of the mole ratio step is the conversion, jumping from one compound to the other. Then the last multiplication you're going to do, actually you're going to multiply the molar mass of ammonia. You have to look that up. And so just like we practiced. Now for part B. Part B, you're starting again at grams of nitrogen, so it's just we're starting right here still. And now we're looking for how many molecules of ammonia. So now, instead of on our chart here, it's fairly close. You're going to start just like we did here, convert it into moles. You're going to use the same mole-mole ratio that you did on the other problem. But now, instead of multiplying by the molar mass, we want to end up over here at number of molecules in this problem. So instead of multiplying by molar mass, you're going to be multiplying by Avogadro's number. And when you do that, it'll be Avogadro's number of molecules of ammonia over 1 mole of ammonia. Question 6, you're starting with, this is your given. This is how many molecules of nitrogen. So now we're starting over here with Avogadro's number of molecules. Okay, so you're right over here. That'll be your given, is 6.02 times 10 to the 23. It reacts, and now we're looking for molecules of hydrogen. So on this problem, we want to find hydrogen now. I'm going to erase where we had NH3 up there. Recommend label this H2. We're looking for hydrogen. So you're going to go from molecule of nitrogen. You're going to divide by the by Avogadro's number this time. That'll give you moles of nitrogen gas. You're going to do the mole-mole ratio. Now we got a new ratio from what we had in the previous two problems. We need to see how many moles of hydrogen in the balanced equation. And in the balanced equation for this one, well, there's 3 moles of hydrogen for every 2 moles, for every 1 mole of nitrogen here. So that's going to be our middle step here, the mole-mole ratio. We're looking for hydrogen, so that's going to be 3 moles of H2. And we started in this problem with nitrogen, so that'll be 1 mole of N2, because in the balanced equation, there's 1 mole of nitrogen. That's where we started, that's where we're going. So in this one, now this one's pretty easy. This one's so easy you probably think it's harder. We're starting with moles of nitrogen. We're starting right here with moles of nitrogen, and the question is asking you how many moles of ammonia are produced. Okay, I'm going to make this ammonia here now, NH3. But what the nice thing is, all you have to do is the mole-to-mole ratio. It's the same mole-to-mole ratio that you use with nitrogen and ammonia that we were using in the first part over here. So there's going to be, so that you just multiply it by this ratio. So that's just going to be a one-step conversion, and that's what's nice about using the triangle, the road map, it lets you see if you're starting here and you got to end over here with moles of NH3, you just have one conversion factor, and it's the mole ratio based on the balanced equation. Okay, for number 2, okay, similar thing. You're starting with grams of oxygen. So I would say, let's change this now to O2. Oxygen exists as O2 in this equation. When you look at the balanced equation over here, it's O2. So you don't want to just put O. And we're looking for how many grams of carbon dioxide. So in the first one, we're going from oxygen to carbon dioxide. So I would recommend on your triangle here, lightly put in that this is now CO2. And we are starting here, what was it, with 64 grams of oxygen. I'm just going to say, okay, we're starting with 64 grams of oxygen right there. And we're looking for grams of carbon dioxide. So we want to end up here. So start with your given. You're going to divide by the molar mass. That'll be 1 mole of O2 over the molar mass of O2. You have to look that up. Then you're going to do your mole to mole ratio. And since we're coming over to CO2, you need moles of CO2 on the top from the balanced equation. And that looks like that's going to be 1 mole of CO2. Well, I'll kind of help with that. Okay, we got 1 mole of CO2 in the balanced equation. And we came from compound A, which in this case hopefully you label oxygen. In the balanced equation, we have 2 moles of oxygen. So that's how you do that. Part B, okay, we're starting with grams of water. How many grams of methane? Okay, so now we're going to grams of water. How many grams of methane? When you look on the chart, methane is CH4. I think it said it on there. Apply that. Okay, so now you're starting at 27 grams of water. Okay, you've got to divide by molar mass of water. You've got to do the mole ratio of how many moles of CH4 compared to how many moles of water. Let's see. Looks like there's 1 mole of CH4, which will be over 2 moles of water. That's going to be there. Next one, part C. 1 mole of CH4 reacted with 2 moles of oxygen. Okay, CH4, 2 moles of oxygen. Okay, so they're given in this problem. Okay, first off, they're just telling you if 1 mole of methane, which we have 1 mole in our equation, reacts with 2 moles of oxygen, okay, there's 2 moles there. We're looking for how many molecules of CO2 were produced. So just start, your given's going to be 1 mole of CH4. Okay, this is just kind of, this part here is just kind of extra info. You don't really need that. That's your given. And now you're at moles. You want to convert to molecules, so you're just going to have to multiply by the correct mole ratio for this problem. And see, since we're converting, let's see how many moles of CO2 are produced. If 1 mole of CH4 reacts, how many molecules of CO2? So you're going to have to do the mole ratio to jump over here to moles of CH4. Oh, sorry, we're on CO2 now. Let me change that. I didn't do that. I should have done at the very beginning because we want to find out for CO2. We're starting, this is now our, in this problem we're saying methane, CH4. Okay, so we're starting here with moles of methane. We need to look at the equation for how many moles of methane compared to CO2. And we've got 1 mole of CO2. We'll go up here. And we're coming from methane, 1 mole. It's a 1-to-1 ratio. But we're not done. We're looking for molecules. So once we get over here after the mole ratio, now we need to multiply by Avogadro's number. So that'll be Avogadro's number there. For part D, helping you set this up, this is our given. We're at molecules of methane. How many molecules of water are produced? So if we start with methane, okay, I've still got this labeled CH4. And we're starting now, we've got this many molecules of, oh, sorry, let me get that adjusted on there. We've got this many molecules, we got half a mole of molecules of methane. You've got to convert that into moles using, by multiplying or dividing by Avogadro's number. Then you've got to, we're looking for, so you got to convert that into moles of, and this is now going to be water because we're going between methane and water. Label this H2O now. So once you find, multiply by the mole ratio of water, moles of water over moles of CH4, then to find molecules, you multiply by Avogadro's number. So there's getting it set up.